40 light years away, a small red star holds 7 worlds, each one roughly the size of the planet beneath your feet right now. For years, we could only guess what wrapped around them. Then, the James Webb Space Telescope turned its golden eye toward TRAPPIST-1, and what it found begins to rewrite the quiet story you carry about whether Earth is rare or simply one note in a much larger song. Tonight you will see those 7 worlds the way no human ever has before. If this slow journey settles your mind, leave a like and subscribe, because these worlds deserve company while you drift. And softly, before we begin, where are you listening from, and what hour glows on your clock? Tonight, before anything else, let your eyes drift upward in your mind toward the sky you think you know. Picture it the way you have always pictured it. A black field scattered with points of light, some brighter than others, a few of them bold enough to have names. You have spent your whole life being told a quiet story about that sky, and the story goes something like this. The stars that matter are the bright ones, the ones you can see, the ones that catch your attention from a city sidewalk or a dark country road, the ones that have guided sailors and inspired poems and filled the windows of every person who has ever looked up and wondered. The bright stars feel important precisely because they are visible. They announce themselves. And somewhere underneath all of that, without ever deciding it on purpose, you came to believe that brightness and importance are the same thing. It is a gentle assumption. It is also almost entirely wrong. Let that settle for a moment, because there is no rush here. The sky is not going anywhere, and neither are you. Breathe slowly, and let me complicate something you have always taken for granted. The bright stars, the ones you can actually see, are the rare ones. They are the exceptions. They are the loud, hot, fast burning giants that flare brilliantly and die young, and they are vastly outnumbered. For every dazzling sun, like the kind you imagine when you think of a star, there are many more that you have never seen and never will, not with your eyes alone, no matter how dark the night or how far you travel from the glow of the cities. These hidden stars are smaller, cooler, dimmer. They burn low and slow, like embers left at the edge of a fire long after the flames have gone, and they will keep burning that way for spans of time so long that the mind simply slides off the numbers. These quiet stars have a name. We call them red dwarfs. And here is the first crack in the comfortable story you have always carried. Red dwarfs are not the unusual case. They are the rule. They are the most common kind of star in the entire galaxy, by a wide and almost startling margin. If you could somehow gather up every star in the Milky Way and sort them by type, the overwhelming majority of them would be these small red embers, glowing faintly in the dark, invisible to the unaided human eye. The bright suns you grew up imagining, the ones that fill our idea of what a star is supposed to be, would be a thin minority lost in the crowd. So the sky you think you know, the sparkling field of visible stars, is not the real sky at all. It is a tiny, filtered sample. It is the loud surface of something vast and quiet underneath. The true galaxy, the one that actually exists out there beyond the reach of your eyes, is mostly dim, mostly red, mostly silent, and mostly invisible to you. I want you to sit with how strange that is. You have looked up your entire life and felt on some level that you were seeing the universe, but you have only ever seen the rarest pieces of it. the bright exceptions. The galaxy has been hiding its true face from you the whole time, not out of any secrecy, but simply because its most common members are too faint to shine through to your waking eyes. Now let me take you to one of them, 40 light years from where you are resting right now, in the direction of a constellation called Aquarius. There is a star. You cannot see it. I want to be honest with you about that from the beginning. Even if you knew exactly where to look, even if you stood beneath the clearest, darkest sky on Earth and traced the precise spot with your finger, you would see nothing there. The star is too faint. It is a red dwarf, one of those quiet embers, and it carries a name that sounds more like a code than a name given to it by the telescope that found it. We call it TRAPPIST-1. It is small, almost unimaginably small for a star. If you placed it beside our own sun, it would look less like a sibling and more like a child standing next to an adult, barely larger than the giant planet Jupiter, that great striped world in our own solar system. A star, but only just. It is cool too, glowing in deep reds and infrared light, much of its warmth pouring out in colors your eyes were never built to catch. It is dim, radiating a tiny fraction of the light our sun pours into space. By every measure that the old story taught you to value, by brightness, by size, by drama, TRAPPIST-1 is nothing. A faint red coal in the dark, a star that should not matter, and yet, hold on to that small word, and yet, because everything in this long, slow journey we are about to take together turns on it. Before we go further, let me give you the distance in a way your body can actually feel, because 40 light years is the kind of phrase that slides past the mind without leaving a mark. We say it so easily, 40 light years. But a light year is not a measure of time. It is a measure of distance, and a staggering one. It is how far light travels in a single year, and light is the fastest thing there is, moving so quickly that in one single second it could circle the entire Earth not once, but 7 times over. Imagine that. 7 laps around the whole planet in the time it takes you to say the word now. That is the speed we are talking about. And light keeps up that impossible pace, second after second, hour after hour, without ever slowing, without ever resting, for an entire year. The distance it covers in that year is 1 light year. Now multiply that by 40. The light that is leaving TRAPPIST-1 at this very moment. The light slipping off that faint red ember right now as you breathe will not arrive at Earth until 4 decades have passed. It will travel through the cold and the dark for 40 years, crossing a gulf so wide that the very idea of crossing it strains against everything in you, and turn it the other way. The light you could in principle gather from that star tonight, if you had a great enough eye, left it 40 years ago. It set out on its journey before some of you were born. It has been traveling the entire time, silent and patient, through a darkness with no edges, just to reach this small blue world. To put it in the scale of a human life, light would need to make that crossing again and again, back and forth, many times over before a person grew from birth to old age. We will never go there. Not you, not me, not anyone alive now, and likely no one for a very long time. The distance is simply too vast for bodies like ours, bound as we are to a single fragile world and a single short span of years. And still, somehow, we have learned to reach across that gulf with light alone, to study a star we can never touch and worlds we can never walk upon. We will come to that. But for now, simply let the distance be what it is. Enormous, quiet, almost holy in its size. So here is this star, faint, small, cool, 40 light years away in the dark. By the old story, it is unremarkable, a nobody among stars. And this is exactly where the old story begins to fall apart, gently, the way a held belief loosens when you finally turn it over in your hands and really look. Because the quiet stars, the red dwarfs, the most common stars in the galaxy, may also be the most crowded with worlds. This is the reframe I want to plant in you now, softly, like a seed, and let it grow slowly over the hours ahead. For a long time, when people imagined other worlds, other planets, perhaps other life, they imagined them gathered around bright suns like our own. It felt natural. We came from a bright sun, so surely life and warmth and water belonged to bright suns. The dim red embers seemed like afterthoughts, too faint and feeble to host anything worth finding. Who would look for treasure beside a dying coal when there were brilliant fires all around? But the galaxy, it turns out, does not arrange itself around our expectations. The dim red stars are not just common, they are patient. They burn so slowly, so frugally, that a single red dwarf can keep glowing for trillions of years, far longer than the entire current age of the universe, far longer than our own bright sun will ever last. They are the long, slow, enduring hearths of the cosmos. And around these enduring hearths, astronomers have begun to find planets, not occasionally, not rarely, again and again and again, until it became clear that worlds may be the rule around these stars rather than the exception. If that is true, and the evidence keeps gathering that it may be, then the picture flips entirely. The galaxy's planets do not mostly orbit grand bright suns. They mostly orbit quiet red embers, the very stars you cannot see, the very stars you were taught not to notice. Most of the worlds out there, perhaps the vast majority of all the worlds that exist, circle stars that are invisible to your eyes. The real estate of the universe is not where you were looking. It never was. And if I told you that surprises you, you would be in excellent company, because it surprised the astronomers too. This was not something anyone simply knew and forgot to mention. It was discovered slowly against the grain of expectation. The people who study these things carried the same comfortable assumptions you did. They, too, looked up at the bright stars and felt that brightness meant significance. They, too, half expected the dim red dwarfs to be barren and uninteresting. The surprise you might be feeling right now, that small, pleasant disorientation as the sky rearranges itself in your mind, is a surprise that the experts felt first. There is no embarrassment in it. The confusion is shared. It is the honest response of any thinking mind meeting a universe that refuses to match its early sketches. So we arrive at TRAPPIST, one with new eyes, no longer a star that should not matter, instead a faint red ember that may be exactly the kind of place where the galaxy keeps its worlds. A quiet hearth, 40 light years away, that turned out to be holding something. We will get to what it is holding. We will get there slowly, the way you would walk towards something precious in the dark, careful not to startle it. For now, it is enough to know that the nothing star, the nobody among stars, became one of the most studied points of light in the entire sky. Telescopes turned toward it, careers bent around it, and the most powerful eye humanity has ever built, an instrument waiting patiently a little further along in our story, who would one day be aimed directly at this small red coal to ask it a question we have been asking since the first human looked up and wondered if we are alone. That question is the open loop I want to leave, gently turning in your mind as you rest. Not to answer yet, just to hold. For a very long time we assumed that warmth and water, and perhaps even life, would prefer the loud bright stars, the dramatic suns, the brilliant fires we can see. It felt right. It felt like life should gather where the light is grandest. But what if that was only ever a story we told ourselves because the bright stars were the ones we could notice? What if warmth and water, and the slow chemistry that might one day stir into something living, do not care at all about drama or brightness? What if they prefer the quiet ones, the patient ones, the long, slow embers that burn for trillions of years in the dark, unseen, unhurried, waiting? What if the universe keeps its most precious possibilities not under the brightest lights, but in the calm, dim corners we were never taught to look at? We do not know yet. That is the truth, and it is a beautiful truth, because not knowing is the doorway to everything that follows. But the question has stopped being idle, wondering. It has become something we can actually pursue, with real instruments and real light gathered across real and enormous distances. Somewhere out there, 40 light years away, a faint red ember is glowing in the constellation Aquarius, and around it, unseen, something is waiting to be understood. For now, let your eyes stay closed. Let the bright sky you always believed in soften and rearrange itself into the truer sky, the dim and patient and crowded one, full of quiet red hearths and the worlds that may circle them. You do not need to hold any of it tightly. Let the distances be vast. Let the star be faint. Let the question stay open. We have all the time in the world to follow it, slowly, gently, into the dark. And the dark, as it turns out, is far more full than you were ever told. So we have our faint red ember, glowing quietly in the dark, 40 light years away, a star that should not matter, and yet. Now, let me tell you how we came to know what it was hiding, because the discovery did not arrive all at once. It came the way most true things come, slowly, in pieces, one quiet shadow at a time. It begins, fittingly, with a small telescope, not one of the great space observatories you might be imagining, not yet. Just a modest instrument on the ground, in the high dry air of the Chilean desert, where the skies are among the clearest on Earth. The telescope had a name that was really an arrangement of initials, and those initials spelled a word, and the word was TRAPPIST. The people who built it had a fondness for a certain kind of carefully made Belgian beer brewed by monks, and they let that fondness slip into the name, a small human warmth tucked into a serious scientific instrument. I tell you this because it matters in its way. The grandest discoveries are made by people with humor and patience, and the willingness to sit night after night watching a faint red star for the smallest flicker of change. And what were they watching for? They were watching for shadows. Here is the gentle trick of it. We cannot see these distant worlds directly. They are far too small, far too dim, lost entirely in the glare of even a faint star at such a distance. But we do not need to see a world to know it is there. We only need to see what it does to the light. When a planet passes in front of its star, crossing the face of it from our point of view, it blocks a tiny sliver of the starlight. The star dims, just slightly, just for a while, and then brightens again as the planet moves on. A small dip, a faint shadow crossing a faint light. If you watch carefully enough, patiently enough, you can catch that dip. And if it happens again, at regular intervals, like clockwork, then you know something is there. Something is circling. A world you cannot see, announcing itself by the shadow it casts. So the small telescope in the desert watched the faint red ember of TRAPPIST, one night after night, gathering the light, looking for the dip, and the dip came. The starlight faltered, dimmed, recovered. Then it happened again, and as the watchers studied the rhythm of those small darkenings, the pattern resolved into something extraordinary. There was not one world there. There seemed to be three. Three shadows, three worlds, three planets circling that quiet star that nobody could see. Three. Already that was remarkable. Three worlds around a dim red dwarf, the kind of star everyone had assumed was barren. The watchers announced it, and the news traveled, and the faint nobody star suddenly had the attention of people all over the earth. But three, as it turned out, was only the beginning. Three was the part of the picture that the small telescope could see. The fuller picture needed a greater eye. That greater eye was already in space. There was, at the time, a telescope drifting through the dark far above the Earth, an observatory built to see in infrared light, the very kind of warm, low light that a cool red star pours out most generously. Its name was Spitzer, and it was perfectly suited to study a star like this one. So the watchers turned Spitzer toward TRAPPIST, one, and they watched, and they waited, far longer and far more precisely than any ground telescope blinking through the Earth's restless atmosphere ever could. And the shadows kept coming, more dips, more darkenings, more worlds revealing themselves one by one in the steady infrared gaze. Now begin counting with me, slowly, because the rhythm of this is part of its wonder. One world, the innermost, closest to the star, whipping around it in just a day and a half. Then another, a second world, a little further out, a little slower in its circling, then a third and a fourth, the shadows falling into their patient repeating patterns, then a fifth, then a sixth, then a seventh. 7 worlds, 7 planets, all circling that single faint red ember, all of them caught by the patient watching of telescopes on the ground and in space. Not 3, 7. A whole family of worlds around a star you cannot see, a star most people would have walked right past in the catalogue of the sky without a second glance. 7 shadows, 7 dips in the light, 7 worlds where the old story had promised emptiness. And here is the detail that makes the breath catch. These were not gas giants. They were not great swollen worlds of hydrogen like Jupiter or Saturn, the kind of planet easiest to find because it is largest and blocks the most light. These 7 worlds were small, rocky, each one of them roughly the size of the planet beneath your feet right now. The planet you are resting on as you listen, Earth-sized worlds. Not one of them, but 7, all gathered around a single quiet star. Worlds you could, in your imagination, stand upon. Worlds with ground, worlds with a surface, with a horizon, with a place to set your weight. 7 Earth-sized worlds around one small red ember. It sounds almost like something invented. It was not invented. It was found in the light, in the shadows, by people watching patiently and counting carefully until the impossible number stood confirmed. Now, let me show you how they are arranged, because the arrangement is stranger and more beautiful than the number alone. When you think of planets circling a star, you probably imagine something like our own solar system. Worlds spread out across great distances, each one far from the next, vast empty gulfs between them. Our innermost planet, Mercury, hugs close to the Sun, and even Mercury sits at a respectable distance, tens of millions of miles out, with nothing but emptiness between it and the fire. The planets of our system are spread thin across a wide and lonely space. That is the picture you carry. Worlds far apart, each keeping to its own remote orbit. Now throw that picture away. All 7 of these worlds, every single one of them, orbit closer to their star than Mercury orbits ours. Every one. The entire family of 7. The innermost world and the outermost world and all 5 in between would fit comfortably inside the single small gap between Mercury and our Sunday picture. That, the whole crowded system, 7 Earth-sized worlds, and all their orbits, tucked into a space smaller than the distance from our nearest planet to its star. They are packed in close, gathered tight around their dim red hearth, circling not in the wide, lonely manner of our own worlds, but in a snug and intimate huddle, like people drawn near to a small fire on a cold night, leaning in toward the only warmth there is. And because they are packed so tightly, something happens that simply does not happen in our spacious solar system. These worlds are near each other, genuinely near, as planets go. Near enough that they are not distant points of light to one another, but neighbors, visible neighbors, looming presences in each other's skies. Let yourself stand, for a moment, on the surface of one of these worlds. Let your imagination set you down on solid rocky ground beneath that low red sun. Look up. In our sky, the other planets, even the brightest ones, are only points of light, no larger than the stars, faint wandering dots that most people never even notice. But on these worlds, it would be entirely different. Look up from the surface of one, and you might see a neighboring world hanging there in the sky, not as a point, not as a dot, but as a disk, a visible globe, a neighboring planet large enough to show a face, the way our moon shows its face to us, a pale curved world suspended above your horizon, and not just one. As these worlds slide past one another in their tight orbits, you might at times see several of them gathered in the sky at once, sister worlds and brother worlds hanging overhead like a family of moons, each one a place, each one a surface, each one large enough to wonder about. Imagine living beneath a sky like that, a sky where the other planets are not rumors of light, but visible globes, swelling and shrinking as their orbits carry them near and far, a slow, silent dance of worlds overhead. Imagine looking up on a quiet evening and seeing another Earth-sized world riding the sky above you, close enough to seem almost reachable, close enough that the loneliness of our own wide solar system would be unimaginable to you. You would never feel alone in space. You would have neighbors. You would have a sky full of company. Let that strangeness settle. There is no need to hurry past it. A whole crowded family of 7 worlds, each the size of your own, huddled close around a single dim red ember, near enough to hang in each other's skies like moons. It is one of the most extraordinary arrangements we have ever found anywhere in the heavens, and it is real, and it is out there right now, circling quietly in the dark of Aquarius, as you breathe slowly in and slowly out. So we have resolved a little of our wonder. The faint nobody star is not barren after all. It is rich, it is crowded. It holds 7 Earth-sized worlds in an intimate huddle, a small warm hearth ringed by a family of planets. The old story is thoroughly broken now. The dim red dwarfs are not empty, at least this one is full. And yet, here, gently, I have to complicate the wonder again, the way the truth always seems to ask us to. Because there is a difference, a quiet but enormous difference, between being Earth-sized and being Earth-like. And it is so easy to let those two things blur together. You hear 7 Earth-sized worlds, and something in you leaps ahead, and you begin to picture 7 Earths. 7 blue and green worlds with oceans and clouds and gentle weather. 7 places where a person could breathe the air and feel the warmth and call it home. The mind wants to make that leap. It is a beautiful leap. But size is only size. To be the same size as Earth is to share one single quality with our world, and one quality alone. It says nothing, yet, about the air. It says nothing about the water. It says nothing about the temperature of the ground or the chemistry of the sky, or whether you could stand there for a single moment without perishing. A world can be exactly the size of Earth and be a scorched and airless rock. A world can be exactly the size of Earth and be a frozen stone wrapped in eternal dark. A world can be exactly the size of Earth and be utterly, completely uninhabitable, as dead and silent as anything in the heavens. Size is a beginning, not an ending. It opens the question, it does not answer it. So we have 7 worlds the size of our own, huddled close around their quiet ember. And the real question, the question we have only just begun to ask, is not how large they are. We already know that. The real question is what they are, what wraps around them, what rests upon their surfaces, whether any of them holds an atmosphere, a sky, a layer of air thin and warm and protective, like the one above you right now, whether any of them could hold water, whether any of them, in the long, slow patience of that trillion-year ember, might be a place where something could live. That is where we are going, but not yet. For now, simply hold the picture, 7 worlds, one dim red fire, a crowded family circling close in the dark, near enough to hang in one another's skies. Let it be enough for this quiet moment to know that the emptiness we expected turned out to be company. And let the deeper question wait, patiently, the way the worlds themselves have waited, circling and circling that faint red ember through the long, unhurried dark, for someone with a great enough eye to finally look closely and ask what they truly are. So we have our 7 worlds, huddled close around their quiet red ember, near enough to hang in one another's skies like moons. And now the question sharpens. Of these 7, are any of them more than just stone and size? Are any of them in the right place? Because place, it turns out, matters enormously. Where a world sits relative to its star may be the difference between a frozen tomb, a scorched desert, and somewhere that water could gather and rest. Let me give you the idea gently, because it is one of the most important ideas in this entire story, and it deserves to be understood in your bones rather than merely heard. Think of a fire on a cold night, not the cosmic kind, the ordinary kind, a campfire, a hearth, a small blaze in the dark. Now imagine yourself sitting near it. If you sit too close, the heat is unbearable. You have to pull back, shield your face, retreat from the scorching edge of it. If you sit too far away, the warmth never reaches you at all, and you sit shivering in the cold just beyond its glow. But somewhere between those two extremes, there is a band, a ring of comfortable distance where the warmth is just right. Not too hot, not too cold. A place where you can settle in and stay, where your body finds the gentle middle between burning and freezing. Every person who has ever sat by a fire knows this band instinctively. You find it without thinking. You shuffle closer or further until the warmth feels right, and then you rest. A star is a fire, and its planets are gathered around it, and the very same thing is true. Too close to the star, and a world is scorched. Whatever water it might have held is boiled away, lifted into vapor and lost, leaving a baked and barren rock turning beneath a merciless light. Too far from the star, and a world is frozen. Any water it holds is locked into ice, hard and still and silent, a world of permanent winter where nothing flows and nothing stirs. But somewhere between those two extremes, around every star, there is a band, a ring of comfortable distance where the warmth is just right, where a world would be neither scorched nor frozen, where water, if it were there, could rest upon the surface as a liquid, not steam rising away into space, not ice locked solid in the cold, liquid water. Water that pools and flows and gathers, water that could fill a basin or lap against a shore. We have a name for that band. We call it the habitable zone. It is a plain and useful name, and it means exactly what it says. It is the zone, the ring, the comfortable distance around a star, where a world could in principle be habitable, where liquid water could exist. And we care so much about that band, we search for it so hungrily around every star we study, for one simple reason. Every form of life we have ever known, every living thing in the only example of life we possess, which is our own world, depends utterly on liquid water. Water is the medium in which life on Earth does everything it does. We do not know for certain that life everywhere must need water, but it is the one thing life needed here, and so it is the first thing we look for out there. Find the liquid water, and you have found the place where life, at least the only kind of life we understand, might have a chance. So now we return to our 7 worlds, and we ask the question that suddenly matters more than any other. Where do they sit relative to their fire? Are any of them in the band? Are any of them at that comfortable distance where water could rest upon the ground? And the astonishing answer is yes. Not one of them, several. Remember how tightly these worlds are packed. All 7 of them huddled closer to their star than Mercury sits to our Sunday. You might think that being so close would mean all 7 are scorched, all of them baked too near the fire. But remember also what kind of fire this is. TRAPPIST, one is not a blazing sun. It is a faint red ember, cool and dim, pouring out only a small fraction of the warmth our sun gives off. And so its habitable zone, its band of comfortable distance, is not far away like ours. It is pulled in close, hugging tight around the small, cool star, exactly where these tightly packed worlds happen to circle. The dimness of the star and the closeness of the worlds work together, and the result is that the comfortable band falls right across this crowded little family. The fire is small, so you sit very near it, and several of these worlds are sitting at precisely the right nearness. The astronomers gave these worlds letters in the order of their distance from the star, beginning with B for the innermost and continuing outward through the alphabet. And as they measured the orbits and calculated the warmth each world receives, Their attention settled on three of them in particular, the worlds named E, F, and G. These three sit within or near that precious band, that ring of comfortable distance, where the temperature could allow liquid water to rest upon a surface. Three worlds, three Earth-sized worlds, around a single nearby star, all sitting in the place where water could, in principle, pool into oceans. Let me be honest with you here, because honesty is part of the wonder. The exact edges of a habitable zone are not a sharp line painted in space. They are soft, they blur. Where precisely the band begins and ends depends on details we cannot fully measure from 40 light years away. Details about each world's air and surface and the way it holds or sheds its warmth. And so you will find that the counting itself is gentle and uncertain. Some careful descriptions say three of these worlds fall in the habitable zone. Others, drawing the band a little wider or judging a borderline world a little more generously, say four. The difference is not a mistake by anyone. It is the natural softness of a question asked across an enormous distance about worlds we have never touched. Three, or perhaps four. Let that small uncertainty stand exactly as it is, unhidden, because it is the true shape of our knowledge. We are not certain of the precise count. We are certain that several of these worlds sit in or near the place where water could rest, and that, even with the softness around the edges, is extraordinary. Now, let yourself feel what this means, because this is the moment in our long journey where the heart lifts. 40 light years away, which is impossibly far for a body to travel, and yet astonishingly near as the galaxy measures things, almost in our own backyard among the hundreds of billions of stars in the Milky Way, there sits a single dim red ember, and gathered around it, in a tight warm huddle, are 7 worlds the size of our own. And of those 7, 3 of them, perhaps 4, sit in the comfortable band where the warmth is just right. 3 nearby Earth-sized worlds where, in principle, water could exist, not as steam and not as ice, but as liquid, as oceans, as lakes, as rain falling and rivers running and shores where waves might lap quietly in the dim red light of a patient star. 3 places where water could rest, within reach of our instruments, near enough that we can actually study them, actually turn our greatest eyes toward them and ask them what they are. For almost all of human history, the question of other worlds where water might pool was pure imagination, a thing for dreamers and storytellers, with no way ever to know. And now, suddenly, there are real places, real worlds with real letters and real measured orbits, sitting in the real band where water could gather, close enough that we can investigate them in our own lifetimes. The dream has acquired an address. 3 of them, in fact, circling a faint red ember in the constellation Aquarius. Sit with that lift for a moment. Let it be as large as it deserves to be. We are not talking about distant fantasy. We are talking about specific worlds, the size of the ground beneath you, sitting in the place where oceans could exist, near enough to study. It is one of the most hopeful arrangements the sky has ever shown us. And now, gently, because the truth always asks this of us, I have to introduce the first crack. Being in the right place for water is not the same as having water, and it is not even close to enough on its own. There is a piece missing from this hopeful picture, a piece so essential that without it the entire promise collapses, and that missing piece is air. Let me explain why. Because it is the hinge on which everything that follows will turn. Imagine a world sitting perfectly in the habitable band, at the ideal, comfortable distance, neither too hot nor too cold. The temperature is right. Water should be able to rest there as a liquid. But now, imagine that this world is bare, a naked rock with nothing wrapped around it, no atmosphere, no layer of air, just stone, exposed directly to the emptiness of space. What happens to water on such a world? It cannot stay. In the vacuum of space, with no air pressing down upon it, liquid water cannot exist at all. It boils away even when it is cold, hissing directly into vapor and escaping into the dark, because it is the weight and the pressure of an atmosphere that allows water to remain liquid in the first place. Without air, the warmth of the habitable zone means nothing. The water simply leaves. The world stays dry and dead, no matter how perfectly placed it is beside its fire. And there is more. An atmosphere does not only hold water down, it holds warmth in. It wraps a world like a blanket, trapping the heat, smoothing it across the whole surface, carrying it from the warm places to the cold places, keeping the temperature steady and livable. Without that blanket, a world swings to terrible extremes, scorching where the light falls and freezing where it does not. The air is what makes a world gentle. The air is what makes it a place rather than merely a stone in the right location. So being in the right place for water means nothing at all without an atmosphere to hold it. The habitable zone is only a promise. It is the comfortable distance from the fire, yes. But a comfortable distance does you no good if you have no skin to keep your warmth, no blanket against the cold, no air around you at all. The location is the invitation. The atmosphere is what lets you actually accept it. And this is where the hope we just felt so strongly meets its first great test. Because we do not know, simply from their place in the band, whether any of these 3 or 4 worlds has air. Their position tells us they could hold water if they had an atmosphere. Their position tells us nothing about whether the atmosphere is there. A world in the perfect place, wrapped in a good thick blanket of air, could be a haven, gentle and warm, with oceans resting on its surface. The very same world in the very same place, but bare, stripped naked of its air, would be a frozen, scorched rock where no water could ever stay. Same distance, same fire, same size, utterly different fates. And the thing that decides between those fates is the one thing we could not see in any of the shadows, any of the dips, any of the patient counting that revealed these worlds to us in the first place. So here, as we slow toward the close of this part of our journey, we arrive at the great unanswered question, the question that everything has been building toward, the question that will carry us forward through all that remains. Do these worlds even have air? Not whether they are the right size, we know they are. Not whether they sit in the right place, we know that several of them do. The question beneath the question, the one that decides whether these are havens or merely well-placed rocks, the one that turns the promise of water into either reality or emptiness, is simply this. Is there an atmosphere? Is there a sky? Is there a thin, warm, protective layer of air wrapped around any of these worlds, the way there is wrapped around the world you are resting on right now? The air you have been breathing slowly and gently this entire time, without once having to think about it. We could not answer that question by watching shadows cross a star. Catching the dip in the light tells you a world is there and how large it is and where it sits. It does not tell you what wraps around it. To answer the deeper question, to actually read the air of a world 40 light years away, we would need something more. a greater eye, a more delicate method, a way to take the faint light that grazes the very edge of a distant world and tease from it the fingerprints of whatever gases might be there. We have built such an eye, and in time we will turn it toward these worlds and ask them, at last, whether they breathe. But for now, let the question rest in you, unhurried and open, the way the worlds themselves rest in their tight orbits around their patient ember. 3 worlds, perhaps 4, sitting in the place where oceans could be, and not one of us yet knowing whether there is any air at all to make those oceans possible. The promise is real. The promise is also, for now, only a promise, and the difference between the two is written in a sky we have only just learned how to read. Before we learn how to read the air of these worlds, there is something else about them you should understand, something strange, something that grows directly out of how close they huddle to their quiet ember. Because that closeness, the very thing that places them in the warm band where water could rest, also does something profound to the worlds themselves. It changes the most basic rhythm of their existence. It takes away something you have never once had to think about, something so woven into your life that you cannot even imagine its absence. It takes away the day, and it takes away the night, or rather, it freezes them both in place, forever. Let me show you what I mean, slowly, because this is one of the most haunting features of these worlds, and it deserves to unfold gently. Think about your own world. Think about the planet you are resting on right now. It is turning beneath you, quietly, constantly. The Earth is rotating, spinning on its axis like a great slow top, carrying you with it. You do not feel the motion, but you see its effects every single day of your life. The sun rises in the east because your part of the earth is turning toward it. It climbs the sky through the morning, stands high at noon, sinks through the afternoon, and sets in the west because your part of the earth is turning away from it. Then comes the night, the long dark hours when your side of the world faces out into space, away from the fire, into the cold and the stars. And then the turning brings the sun back again, and dawn breaks, and the whole cycle begins anew. Day and night, light and dark, the steady breathing rhythm of a spinning world. You have lived inside that rhythm every moment of your entire life. It is so constant that you never question it. The sun always returns. The night always ends. The day always comes back. Now I want you to imagine a world where that never happens, where the sun rises once and then simply stays, where it climbs to a certain place in the sky and stops there and hangs there, motionless, hour after hour, year after year, century after century, never moving, never setting, never sinking toward any horizon. A world where, if you stood in one place, the sun would be fixed forever at the same point in the sky, casting the same shadows, shedding the same unchanging light for all of time. That is very likely the fate of these worlds, and the reason is the closeness. When a world orbits very near to its star, the star's gravity does not simply hold it in its orbit. It also reaches into the world itself and grips it, takes hold of its rotation, and slowly, over immense spans of time, drags that rotation into a kind of lock. The pull of the star tugs hardest on the side of the world nearest to it, gently, persistently, across millions and millions of years, until the world's spin is brought into perfect step with its orbit. And once that happens, The world turns to keep one single face pointed at its star at all times, always the same face. The way our own moon keeps one single face turned toward the Earth, so that from here we only ever see one side of it and never the other, no matter how long we watch. The moon is locked to us in exactly this way. And these 7 worlds, huddled so close to their faint red ember, are very likely locked to it the same way. One face turned toward the fire, forever. Let yourself feel what that would actually mean to stand upon such a world. On one side, the side that faces the star, it is always day. Not morning, not afternoon, just a single endless noon that never moves and never ends. The faint red sun hangs fixed in the sky at the same spot it has always occupied, neither rising nor setting, simply there, a low, dim, crimson light pouring down without pause. There is no dawn on this side, because there was never a night for the dawn to break. There is no sunset, because the sun will never sink. There is no evening, no morning, no passage of hours marked by a moving light. There is only the changeless red glow, holding still in a sky that never turns. Imagine living your whole life beneath a sun that never once shifts its position. Imagine that the light outside your window is exactly the same in what you might call the deepest hour of night as it is in the brightest part of the day, because there is no night and there is no day, only the one fixed, unblinking eye of the star, watching its world forever from the same place in the sky. And then there is the other side. Turn away from the fixed red sun. Walk in your imagination around the curve of this world, away from the star, toward the side that faces out into space. As you go, the sun sinks lower behind you, not because it is setting, but because you are walking out from under it, until at last you cross to the far hemisphere, the side that never faces the star at all. And here it is night, but not the night you know, not the gentle passing dark that you trust will end at dawn. This is a night with no dawn anywhere in its future, a permanent, eternal midnight. The star never rises here. It has never risen. It never will. This hemisphere has been turned away from the fire since the world first locked into place, and it will stay turned away until the star itself dies. The sky here is black and full of stars, and perhaps the looming disks of neighboring worlds, but the sun, the source of all warmth, is simply gone, hidden forever beyond a horizon it will never climb. And so this side is cold, bitterly, deeply, endlessly cold, a frozen dark hemisphere where the warmth of the star has never once fallen, where ice could lie undisturbed for the entire lifetime of the world, where the silence and the stillness and the dark go on and on without any promise of morning. One world, two halves, an eternal blazing noon on one side and an eternal frozen midnight on the other, and never, anywhere, the simple miracle you have known every day of your life, the turning of light into dark and dark back into light. Now here is the part that holds the deepest wonder. Between those two extremes, between the endless day and the endless night, there is a band, a ring, a thin circle that runs all the way around the world, dividing the bright half from the dark half, where the sun sits forever low on the horizon, not high overhead, scorching, not gone entirely, freezing, but low, perpetually low, like an eternal sunset that never finishes setting, or an eternal dawn that never quite breaks. a ring of permanent twilight, wrapping the whole world in a circle, where the light is soft and red and slanting, where the sun hangs always at the edge of the sky in a long, unending dusk. And it is in that ring, perhaps, that the most interesting possibilities live. Think about it gently. The day side may be too hot, too exposed, baked beneath the unmoving sun. The night side may be too cold, frozen solid in its eternal dark. But the twilight ring, the band between them, might be just right. Soft light, gentle warmth, a place where the scorching and the freezing meet and cancel into something livable. If any of these worlds hold an atmosphere, and if any of them hold life, it might cling to that ring. A circle of perpetual twilight running around the whole world, a band of soft red dusk where the temperature settles into something gentle, where water could pool without boiling away or freezing solid, where whatever might live there would live always in the long, quiet light of an eternal evening. Imagine a whole living world gathered into a ring of dusk. Imagine that the only habitable place is the line between the endless day and the endless night, a thin, bright circle of twilight holding everything that could ever stir or grow. But there is something that complicates even this, and it is worth understanding because it softens the harshness of the picture. A world like this, with a blazing side and a frozen side, would seem destined for unbearable extremes. And yet, if such a world has an atmosphere, the air itself would fight against those extremes. The air would move. It would have to. Heated on the day side, it would rise and flow toward the cold night side, and chilled there, it would sink and flow back again. A great endless circulation of wind, sweeping warmth from the bright hemisphere toward the dark one. The atmosphere would work like a vast machine carrying heat around the world, trying always to even out the difference between the scorched and the frozen. With enough air, that wind might carry just enough warmth to the night side to keep it from freezing utterly, might soften the blazing day side just enough to make it bearable, might spread the gentleness of the twilight ring a little further around the world than you would expect. The air, once again, is everything. The air is what could turn a world of brutal halves into a world that breathes, that moves, that smooths its own extremes into something a living thing might endure. But notice how that brings us back, quietly, to the very question we left open. All of this, the livable twilight ring, the warming winds, the chance of a gentle band where something could survive, all of it depends entirely on whether there is air at all. A locked world with a thick atmosphere might be a strange but livable place, its winds forever carrying warmth from the day side to the night side, its twilight ring soft and habitable. The very same locked world, but bare and airless, would be the cruelest of extremes, a face of scorching rock and a face of frozen stone with nothing between them but a sharp and deadly line. The lock is the same. The fate is utterly different. And once again the difference is the air. Let yourself rest now in the strangeness of it all. A world that does not turn, a sun that does not move, a day that never ends, and a night that never breaks. Contrast it, gently, with where you actually are. You live on a spinning world, a world that turns you faithfully through light and dark, that gives you your mornings and your evenings, that lets the sun rise and climb and set, and lets the merciful night come down so you can rest. You have a night to sleep in. These locked worlds do not in the way you know it. On their day side, the sun never lets go. On their night side, the dark never lifts. Only in the twilight ring is there anything like balance, and even there, The light never changes, the dusk never deepens or brightens, the long red evening simply holds forever. And of the two halves, let your mind drift now toward the dark one, the frozen night hemisphere, the vast, still silent expanse that faces away from the fire into the deep of space, where the star has never risen and never will, where the cold has settled in completely and the dark is absolute and unbroken. There is something in that image, for all its harshness, that is strangely peaceful. A whole half of a world wrapped in permanent night. No sun to wake you, no dawn to pull you up. No turning of the sky to mark the passing hours. Only the stars overhead, steady and unmoving, and the deep, quiet cold, and the stillness that goes on and on without end. A hemisphere of eternal midnight, holding its silence beneath a fixed field of stars far across the dark from us, circling its faint red ember in the patient quiet of 40 light years away. Let that stillness settle over you now, the way it settles over that frozen far side of a distant locked world, the sun that will never rise, the night that will never end, the deep, unchanging, dark, soft, and quiet and complete. And while those worlds hang motionless in their long, fixed evening, with one face in eternal light and one face in eternal night, you can do the thing they cannot. You can let your own night come down gently. You can let the dark be a place of rest rather than a place of cold. And as you drift, you can carry with you the image of that far frozen hemisphere, silent beneath its stars, turning slowly through space, holding its endless peaceful midnight 40 light years away in the quiet dark of Aquarius. So we have arrived at the great question, the one that decides everything. Do these worlds have air? And now I want to show you something that should not be possible. I want to show you how we can answer that question about a world we cannot see, a world 40 light years away, a world so small and so dim and so lost in the glare of its star that no telescope we have ever built or ever will build can simply look at it and behold it directly. We cannot see these worlds, and yet we can read their air. Let me show you how, because the method is so quietly miraculous that once you understand it, the universe will feel a little more open to you than it did before. Begin with the problem, stated plainly. These worlds are invisible to us. Even our greatest instruments cannot resolve them as anything more than nothing, because the faint light they might reflect is utterly drowned in the flood of light from the star right beside them. Imagine trying to see a single firefly hovering next to a searchlight from miles away. The firefly is there, but the searchlight erases it. That is the situation with these worlds. They are fireflies beside a searchlight, lost in the glare. So if we cannot see them, how could we possibly know what gases wrap around them? How could we read an atmosphere we cannot even glimpse? The answer is that we do not look at the world. We look at the light, and we wait for a very particular moment. Remember how we found these worlds in the first place. We found them by their shadows, by the small dip in the starlight when a planet passes in front of its star. That same moment, the transit, the crossing of the world over the face of the fire, turns out to be the key to everything, because something extraordinary happens during that crossing, something subtle that you would never notice unless you knew to look for it. When a world with an atmosphere passes in front of its star, most of the world is a solid disk, an opaque circle of rock that simply blocks the light behind it. But around the very edge of that disk, around the rim of the world, there is the atmosphere, a thin ring of air wrapping the planet, transparent enough that light can pass through it. And as the world crosses the star, a thread of that starlight does not get blocked. Instead, it passes through the rim of the atmosphere, slipping through that thin ring of air on its way to us. The light grazes the edge of the world, travels through the layer of gas wrapped around it, and continues on across the 40 light years to reach our waiting instruments. A thread of starlight filtered through the very air of a distant world. And here is the quiet miracle. That thread of light is changed by its passage. It carries a message. Let me give you the feel of it with something you can hold in your hand. Imagine a glass of water held up to a window in the late afternoon light. Look at the glass straight on, through the middle, and the light passes through cleanly. But look at the rim, the curved edge of the glass, where the light enters at a slant and travels through the most water before it reaches your eye. At that edge, the light bends, it gathers, it shifts. The rim is where the light interacts most with what it passes through. The rim is where the water leaves its mark on the light. Now imagine that instead of a glass of water, it is the curved edge of a whole world's atmosphere, and instead of bending the light, the gases in that air do something even more revealing. They drink it. They drink specific colors out of it and leave the rest untouched. This is the heart of the method. So let me slow down and make it clear, because it is beautiful. Light, the white light of a star, is not really white. It is all the colors woven together, every shade of the rainbow blended into one. You know this already in your body, from every rainbow you have ever seen, where the white light of the sun is spread out into its hidden colors by drops of rain. Starlight is the same. It contains every color blended. And here is the crucial thing. Every kind of gas, every molecule, drinks its own particular colors of light and no others. Water vapor drinks certain very specific shades. Carbon dioxide drinks different ones. Methane drinks others still. Each gas has its own appetite, its own precise set of colors it absorbs, like a signature, like a fingerprint that belongs to it and to nothing else. Wherever that gas is present, those exact colors go missing from the light, drunk away, leaving small dark gaps in the rainbow where the color should have been. So picture it now. The thread of starlight passes through the rim of a distant world's atmosphere, and as it passes, whatever gases are in that air drink their particular colors out of it. If there is water vapor in the atmosphere, the colors that water vapor drinks go dim. If there is carbon dioxide, its colors go dim. If there is methane, its colors go dim. The light that finally reaches us across the 40 light years is no longer complete. It has gaps in it, dark notches where specific colors have been quietly removed by the gases of a world we cannot see. And if we can spread that light out into its colors, into its full rainbow, and study exactly which colors are missing, then we can read directly the gases that took them. The missing colors are a message written by the atmosphere itself. They are the fingerprints of the air. We call this transmission spectroscopy. Spectroscopy, the spreading of light into its colors to read what is written there. Transmission, because the light is transmitted through the atmosphere on its way to us. Put together, it is a way of reading the air of a world by studying the light that has passed through it. We never see the world. We only see its star, dimmed and notched by the thread of light that grazed the planet's edge. But in those notches, in those missing colors, the world tells us what it is made of. It cannot help but tell us. The light carries the truth across the dark, whether the world intends it or not. Sit with how astonishing that is. We are reading the chemistry of an atmosphere wrapped around a rock the size of the Earth, 40 light years away, a rock we cannot see and will never visit. By catching the faint thread of starlight that slipped through the thin rim of its air during the few hours it crossed the face of its star, we are reading a world's breath in the colors missing from a light that left it 40 years ago. This idea did not arrive fully formed. Like the discovery of the worlds themselves, it came slowly, carried by patient minds across many years. Decades ago, when the first planets around other stars were only beginning to be found, there were scientists who looked ahead and imagined this very thing. They reasoned it out before any instrument could do it. They understood that one day, when a world crossed its star, light would filter through its atmosphere and carry away the fingerprints of its gases, and that if we ever built a telescope sensitive enough, we could read those fingerprints and learn what distant worlds were made of. It was, at the time, almost a dream, a method described on paper long before any machine could perform it. The vision was there, waiting, decades ahead of the tools, and the people who first imagined it could only trust that someday the instruments would catch up to the idea. For a long time they did not. The early space telescopes tried. They turned their eyes toward distant worlds and gathered what light they could, and they managed real and important things, ruling out certain kinds of atmospheres, catching the largest and easiest signatures around the biggest worlds. But the small rocky worlds, the Earth-sized ones, around faint red stars, remained out of reach. The signal was simply too faint. The notches in the light were too small, too subtle, buried beneath the limits of what those instruments could measure. The dream of reading the air of an Earth-sized world stayed a dream, just past the edge of the possible, for years and years. And then we built a greater eye. The James Webb Space Telescope was made, in part, for exactly this. It is the largest, most sensitive eye humanity has ever sent into space, and it was designed to see in infrared light, the very kind of low, warm light that pours most generously from cool red stars and carries the fingerprints of so many important gases. It waited at a special point far beyond the moon, in the deep cold and dark where its great mirror could gather light undisturbed, reaching past the wavelength limits and the trembling instabilities that had held the earlier instruments back. With this telescope, for the first time, the dream described decades ago on paper became something we could actually do. We could turn this enormous eye toward a faint red ember 40 light years away, wait for one of its 7 worlds to cross its face, and catch the thin thread of starlight filtering through the rim of that world's atmosphere, and read, at last, whatever gases might be written there. But do not imagine it as easy, even now, even with the greatest eye ever built. This is where I want you to feel the delicacy of it, the almost unbearable fineness of the measurement, because it is in that delicacy that the wonder deepens. The amount of starlight that passes through the rim of a small world's atmosphere is staggeringly tiny. The world blocks only a minuscule fraction of the star to begin with, a faint dip in the light, and the atmosphere is only the thinnest sliver around the edge of that already tiny disk, a ring thinner, in proportion, than the skin on an apple. The thread of light that filters through that sliver, the light that carries the entire message, is fainter than almost anything we have ever tried to measure across such a distance. We are looking for changes in the starlight so small, they are like detecting whether a single distant lighthouse has been dimmed by a moth passing across its rim. The notches we are hunting for, the missing colors that betray the gases, are so faint they hover at the very edge of what even this magnificent telescope can detect. We are, in a real sense, counting the few molecules of light that manage to slip through the air of a world 40 light years away and survive the journey to us. A few threads of light, read across an ocean of dark that light itself needs 40 years to cross. And the work of reading them is slow, so slow. It is not a glance, it is not a photograph snapped in an instant. To gather enough of that faint filtered light to read it at all, the telescope must watch the same world cross the same star again and again, transit after transit, patiently collecting the dim thread of light each time, adding it together, building up the signal over many crossings and long hours of careful observation. And then comes the even harder work, the work done not in space, but on the ground, by people, because the faint signal is tangled up with noise, with the natural restlessness of the star, with countless tiny effects that have to be understood and stripped away with enormous care before the true message can be read. Teams of scientists, dozens of them, from many countries, working together for months and years, correcting and checking and questioning the data, separating the whisper of the world's atmosphere from everything else that might mimic or mask it. They argue, they doubt, they test one another's conclusions, they refuse to claim more than the light can honestly support. I want you to hold a quiet admiration for those people as you rest. Think of the patience it takes. Think of the years of careful, painstaking, often frustrating work that go into reading a few notches in a thread of light. There is no drama in most of it, no single triumphant moment, only the long, slow discipline of people who have decided that one of the oldest questions, the question of whether other worlds might breathe, is worth this much patience. They sit with faint and stubborn data for months. They correct for things most of us will never understand. They hold themselves to a standard so careful that they would rather say, "We do not yet know," than claim something the light cannot prove. That patience, that honesty, that willingness to work at the very edge of the possible for the sake of an answer that may take years more to arrive, is one of the most beautiful things our species does. So this is how we read the air of a world we cannot see. We wait for it to cross its star. We catch the thread of light that filters through the rim of its atmosphere, the way light passes through the curved edge of a glass of water. We spread that light into its colors and look for the gaps, the missing shades drunk away by whatever gases are there, each gas leaving its own unmistakable fingerprint. We gather that faint, filtered light over many patient crossings with the greatest eye we have ever built, and then we work, slowly and humbly, to read the message it carries across 40 light years of dark. And with that method in hand, with that delicate, miraculous method, we did the thing the dreamers imagined decades ago. We turned the great eye toward the faint red ember in Aquarius. We waited for its worlds to cross its face, and we began, at last, to read their air. What we found there, in those threads of filtered light, is where we go next. But for now, simply rest in the wonder that it can be done at all, that a few molecules of light, slipping through the edge of an unseen world, and traveling 40 years through the dark, can be gathered and read by patient hands and made to tell us what a distant world is made of. So we turned the great eye toward the faint red ember, and we waited for its worlds to cross its face, and we caught the threads of light that filtered through their rims, and we read them. And now I will tell you what they said. I will tell you calmly and honestly, exactly as the light revealed it, because the truth here is more interesting than any tidy story we might wish for. The answer is not a simple yes. It is not a simple no. It is something far more human, far more like the real edge of real knowledge, where certainty thins out into careful, honest wondering. Let me begin by telling you how much we have actually learned, because it is less than all 7 worlds and more than you might expect. Of the 7 planets circling that star, the great eye has gathered light from all of them. But the careful reading, the detailed studying and reporting of what the light contains has so far been described for the inner 4. The 4 worlds closest to the star, the ones labelled in order of their distance, B, then C, then D, then E. These 4 have been examined closely enough that scientists have been willing to speak about them, cautiously, in the pages where such findings are recorded. The outer 3 remain less explored for now, their light still being gathered, their stories still waiting to be told. So our journey through the findings is a journey through these inner 4, moving outward, world by world, from the one nearest the fire toward the one that interests us most of all. Begin with the innermost, the world called B. It orbits closest of all to the red ember, whipping around it in a span shorter than 2 of your days, bathed in far more of the star's warmth than any of its siblings. When the great eye read the light from this world, it looked for the signs of an atmosphere, the notches, the missing colors, the fingerprints of gases wrapped around it, and it found, in essence, nothing. No thick blanket of air, no clear signatures of gases drinking colors from the light. The most honest reading of the data is that this innermost world is very likely a bare rock, a naked stone turning beneath its star with no atmosphere to speak of, its surface exposed directly to the emptiness of space. There is no sky there, no air, no protective blanket, just rock and light and the cold beyond. The closest world to the fire appears to have been left, as best we can tell, utterly bare. This is worth pausing on gently, because it is a real answer even though it is not a hopeful one. For one of these worlds, we now have a genuine reading, and the reading is that it has no air. The dream of an atmosphere on the innermost world has not been confirmed and complicated. It has, quietly, been set aside. A bare rock, that is what the light suggests. And there is a kind of honesty in receiving that without disappointment, simply as knowledge we did not have before. Move outward now to the second world, the one called C, a little further from the star, a little cooler, a little less fiercely lit. When the great eye read its light, the answer was not quite as stark as for the innermost world, but it was close. If this world holds any atmosphere at all, it is at most a very thin one, not a thick protective blanket, not a substantial sky, at best a faint wisp of air, and quite possibly almost nothing. The data does not support a generous atmosphere wrapped around this world. It points, again, toward a place that is mostly bare, or nearly so, a world with little or no sky to hold warmth or water. So the second reading, like the first, leans toward emptiness, thin air at the very most, likely far less. Now the third world, the one called D. And here something important shifts, because this world sits near the inner edge of that precious habitable band, the comfortable distance where water could in principle rest. So our hopes naturally rise as we approach it. A world near the habitable zone. Surely this one might hold a real atmosphere, a true sky, the kind of blanket that could make it gentle. The great eye read its light carefully, and what it found was, again, a narrowing of the possibilities rather than a hopeful confirmation. For this world, an Earth-like atmosphere has been ruled out. The light does not support the kind of air that wraps our own world, the thick protective sky that holds our oceans and smooths our climate and lets us live. Whatever this world is, it does not appear to be a second Earth wrapped in Earth-like air. That particular hope, for this particular world, the light has quietly closed. Notice the pattern as we have moved outward. Bare rock, thin air at most, no Earth-like atmosphere, 3 worlds, 3 careful readings, and each one has narrowed the dream rather than fulfilled it. You might feel, as we reach this point, a certain settling of the heart, a sense that perhaps the answer to our great question is turning out to be no. Perhaps these worlds, for all their promise, are simply bare. Perhaps the faint red ember stripped them all naked long ago, and the warm band where water could rest holds nothing but exposed stone after all. But we have one more world to reach, the 4th, the one that has held our attention from the beginning, the world called E. Let me slow down here, because this is the heart of everything, and it deserves to be approached gently and read honestly. The world E sits squarely in the habitable zone, that comfortable band where the warmth is just right, where water could in principle pool into oceans if only there were air to hold it. Of all 7 worlds, this one has long been considered the most tantalizing, the best nearby chance, the place where, if anywhere in this system, the conditions for life might gather. And so when the great eye turned to read its light, the stakes were as high as they have ever been in this kind of work. This was the world we most wanted to understand. This was the one whose answer might change how we think about our place in the universe. So the telescope watched this world cross its star, not once, but several times, gathering the faint thread of light that filtered through its rim across multiple crossings, building up the delicate signal with great patience. And then the long, careful work of reading began, the months of separating the world's whisper from the restless noise of the star. And what emerged, when the reading was done, was not silence. It was not the clear emptiness of the inner worlds. There were hints, faint, careful, tantalizing hints of something there. The light suggested that this world might hold an atmosphere after all. Not a thin wisp like its neighbors, but something more substantial, an atmosphere made of heavier gases. The data hinted at an air that might be rich in nitrogen, the very gas that makes up most of the air you are breathing right now, the quiet, abundant gas that forms the bulk of our own sky. And woven into that hint was another, even more evocative, traces of methane, a whisper of that gas in the filtered light, the kind of signature that sets the mind racing, because methane is a gas that can be tied, in some circumstances, to interesting chemistry, even on our own world, to living things. An atmosphere rich in nitrogen with traces of methane. If that is truly what wraps this distant world, then it would be something genuinely remarkable. It might resemble, a little, the thick, hazy, nitrogen-rich air of Titan, the strange moon of Saturn in our own solar system. Or it might resemble, even more thrillingly, something a little like the early air of our own Earth, a real atmosphere, a real sky, on a world in the habitable zone 40 light-years away. Feel the lift of that. After 3 worlds that narrowed the dream, here at last is a world that seems to widen it again. Hints of a genuine atmosphere, of heavier gases, of nitrogen, and a trace of methane, on the one world we most hope to find them. It would be so easy, here, to declare a triumph, to say that we have found it, an atmosphere on a habitable zone world, a sky wrapped around a distant Earth-sized planet, the first real candidate for a living world beyond our own. The temptation to round the hint up into a certainty is enormous, and this is exactly where the honesty of real science becomes its own kind of beauty, because the people who did this work refused that temptation. And so will we, because the very same light that hinted at a nitrogen-rich atmosphere with traces of methane also fits other answers, quieter answers. The same data, read honestly, is also consistent with this world being a bare rock, just like its inner siblings, with no atmosphere at all, the apparent hints arising from the noise of the restless star rather than from any true sky. And the same data is also consistent with a world whose atmosphere, if it has one, is hidden entirely beneath a thick layer of cloud, so that the light tells us almost nothing about what lies below. 3 possibilities, all fitting the same faint thread of filtered light: a real nitrogen-rich atmosphere, a bare rock, a world veiled in cloud. The light, as it stands, cannot yet choose between them, so we do not know. After all of it, after the great eye and the patient crossings and the months of careful reading, the honest answer for the most tantalizing world of all is that we do not yet know whether it breathes. The hints are there. They are real hints, not nothing, and they lean in a direction that quickens the heart. But they are not proof, and the people who found them are the first to say so, urging caution, insisting that the right first question is still the simplest one, whether an atmosphere exists there at all, and reminding us that a trace of methane glimpsed in the light might come not from the world, but from the troublesome star itself. I want you to sit with that uncertainty rather than feeling cheated by it, because there is something profound in it. We are standing, right now, in this moment of history, at the very edge of knowing, not on one side of the question or the other, not in the comfort of a clear yes or a clear no, but balanced precisely on the thin line between them. We have a world in the habitable zone, 40 light-years away, that might have a nitrogen-rich sky with a trace of methane, or might be a bare rock, or might be hidden under cloud, and we cannot yet tell which. The thread of light has carried us right up to the threshold of an answer, and then left us there, peering forward into a question that has not quite resolved. There is a particular wonder in that edge. It is the wonder of a thing almost known. For all of human history, the question of whether other worlds hold air and water and the possibility of life was pure imagination, with no way ever to approach it. And now we are not imagining, we are measuring. We have turned our greatest eye toward a specific world with a name, and we have gathered real light that passed through whatever sky it may have, and we have found real hints that lean towards something extraordinary. And we have been honest enough to say that the hints are not yet certainty. We are no longer dreaming about distant worlds. We are reading them carefully, at the very limit of what is possible, and finding ourselves poised at the threshold of an answer we can almost, but not quite, make out. So rest tonight in that ambiguity and let it be beautiful rather than frustrating. Somewhere out there, a world called E is circling its faint red ember in the dark of Aquarius, and it may be wrapped in a quiet nitrogen sky with a breath of methane, or it may be a bare and silent stone, and we do not yet know which. And the not knowing is itself a kind of marvel, because it means the answer is finally close enough to chase. We are standing at the edge of knowing, and the edge, it turns out, is one of the most wondrous places a curious mind can stand. So we stand at the edge of knowing with hints that lean toward a sky and refuse to become certainty. And now I want to slow down and tell you why. Why this is so hard. Why the answer keeps slipping just out of reach even with the greatest eye we have ever built. Because the difficulty is not a failure of the telescope, and it is not a failure of the people. The difficulty lives in the star itself. The very thing that makes these worlds possible is also the thing that makes them so maddeningly hard to read. And understanding that, gently, will change how you see the whole endeavor. Come back to the star, the faint red ember. For most of this journey, I have described it as quiet, as calm, as a patient hearth glowing low in the dark. And in the grand scale of its life, that is true. It will burn for trillions of years, slow and frugal, long after brighter stars have died. But quiet over the span of trillions of years does not mean still in any given moment. Up close, in the day-to-day reality of its existence, this star is not calm at all. It is restless, it is troubled, it seethes and flickers and erupts in ways our own steady sun rarely does. The small red dwarfs, for all their endurance, are among the most temperamental stars there are, and TRAPPIST, one is no exception. Let me show you what that restlessness looks like, because it matters enormously for everything we are trying to learn. The surface of this star is mottled, spotted, covered in dark patches, regions cooler and dimmer than the rest, that drift across its face as it slowly turns. Our own sun has spots too, but on a star like this they can be larger, more numerous, more dramatic relative to the whole. And these spots are not fixed. They appear and fade and migrate, so that the face of the star is always changing, never quite the same from one observation to the next. The light pouring off it shifts and flickers as these darker and brighter regions wheel into view and out again. The star, in other words, is not a steady lamp. It is a living, churning surface, mottled and uneven, casting a light that trembles and varies in ways all its own, having nothing to do with any planet at all. And then there are the flares. Sudden, violent eruptions of light and energy bursting from the star's surface, flooding outward in great surges of radiation. Where our sun flares occasionally and modestly, a small red dwarf like this can flare often and fiercely, sometimes brightening dramatically in a matter of moments, hurling out waves of energy far stronger, relative to its size, than anything our own sun typically produces. The star is prone to these eruptions. It is, in a real sense, a stormy star, an ember that does not merely glow, but crackles and bursts and throws its energy outward in restless fits. Now hold that picture of a restless, spotted, flaring star alongside the delicate method we use to read its worlds. Remember what we are doing. We are catching a faint thread of starlight that filtered through the thin rim of a planet's atmosphere, and we are looking for tiny notches in it, small missing colors that betray the gases of a distant sky. The entire method depends on the starlight being understood. We need to know what the light looked like before the planet touched it, so that we can tell what the planet changed. We are measuring a whisper against the background of the star, and we have been assuming, for the sake of the method, that the star is a steady and well-behaved source of light, but it is not. It is mottled and flaring and restless, and so a terrible confusion arises. The deepest difficulty in all of this work, the star itself drinks colors out of its own light. Its spots, its cooler and hotter regions, its eruptions, all of these leave their own marks on the starlight, their own notches and shifts and variations. And those marks can look, to our instruments, almost exactly like the marks a planet's atmosphere would leave. A fingerprint that we believe belongs to a distant sky might, in truth, belong to the star. A trace of a gas we think we have found wrapped around a world might actually be a feature of the restless surface of the ember itself, a shadow of a star spot, a residue of a flare, masquerading as the breath of a planet. This is the trouble at the center of everything. When we read the light and find a hint of methane around that tantalizing world, we cannot be fully certain whether the methane is really there in the world's air, or whether the signature comes from the troublesome star, its churning surface imprinting a false fingerprint onto the light before the planet ever touched it. The star contaminates the very readings we are trying to take. It writes its own messages into the light and tangles them up with the messages from the worlds, until separating the two becomes a labor of immense difficulty. The whisper of the planet and the noise of the star arrive woven together and pulling them apart, deciding which mark belongs to the world and which to the ember, is one of the hardest things this kind of science has ever attempted. And that is why the answer keeps refusing to resolve. Not because the worlds are silent, and not because the telescope is weak, but because the star will not hold still long enough to let us read its planets cleanly. Every measurement is a measurement taken against a moving, flickering, erupting background. Every hint must be weighed against the possibility that the star, not the world, produced it. The restlessness of the ember is the fog through which we are straining to see, and it will not simply lift. But here is where the story turns, gently, towards something deeper than mere difficulty. Because that same restless energy, those same fierce flares that trouble our readings, have likely also shaped the fate of these worlds in profound and double-edged ways. And this is one of the most haunting truths in all of it. Consider what billions of years of flaring would do to a world huddled close to such a star. The inner worlds, pressed near the ember, would have been bathed again and again in those violent surges of radiation, storm after storm, eruption after eruption, across spans of time so long they defeat the imagination. And radiation like that is not gentle. It can strip a world. It can tear away an atmosphere over the ages, blasting the air off into space bit by bit with each great flare, until a world that might once have held a sky is left bare. This may be exactly why the innermost worlds appear to be naked rock, not because they never had air, but because the restless star, over billions of years, may have torn that air away. The very flares that contaminate our readings may also have written the bare and airless fate of those inner worlds long before we ever looked. The star is destructive. Its energy can leave its children stripped and silent. And yet, hold on to that small word again, because it returns here with the deepest meaning it has carried in our whole journey. That same fierce energy, that same flood of radiation, has another face entirely, because energy is also what stirs chemistry into motion. Energy is what drives reactions, what breaks and forms the bonds between atoms, what can take a still and lifeless mixture of simple substances and provoke it into the complicated dance from which interesting things, perhaps even living things, might one day emerge. The same flares that could strip a world bare could, on another world, or in another circumstance, deliver exactly the jolt of energy needed to kickstart the chemistry that life requires. The radiation that destroys might also create. The storms that strip an atmosphere from one world might spark, in the right conditions, the very chemistry that life depends upon in another. This is the double edge of the restless star, and it is almost unbearably beautiful in its ambiguity. The flares are both a threat and a gift. They are the destroyer of skies and the possible igniter of life. They could be the reason these worlds are bare, or they could be the reason one of them might, against all odds, hold the first stirrings of something living. The same energy. Two utterly opposite possibilities. And which one came to pass on any given world, we do not yet know. The star that makes our work so hard is the same star whose violent heart may hold both the death and the spark of these worlds at once. So we return to the people who do this work, and I want to honor them now, in light of all this difficulty, because faced with a restless star that contaminates every reading, faced with fingerprints that might belong to a world or might belong to the ember, faced with a double-edged energy that could mean barrenness or beginnings, they have responded not with overreaching claims, but with caution, with humility, with a careful, disciplined honesty that refuses to say more than the light can prove. When the hints of an atmosphere appeared around that tantalizing world, there were scientists who immediately urged restraint, who reminded everyone that the right first question, the most basic question, is still simply whether an atmosphere exists there at all, and that until we can be sure the signatures come from the world and not the star, we must hold our excitement in check. They argued for more study. They called for stronger evidence. They were willing, in the face of a discovery they surely longed to make, to say plainly that we are not there yet. I want you to see that not as disappointment, but as something admirable, something even moving. It would be so easy to round the hints up into a headline, to claim a habitable world found, to let the longing outrun the evidence. The people doing this work refused. They held themselves to the harder standard, the slower standard, the one that says we would rather be honest and uncertain than confident and wrong. That refusal, that insistence on caution in the very moment when triumph beckoned, is not the failure of discovery. It is the proper humility of real discovery. It is what makes the eventual answer, whenever it comes, worth trusting. The willingness to stand at the edge of knowing and say honestly that we do not yet know is not weakness. It is the deepest strength the searching mind possesses. And so let this part of our journey settle into a gentle truth about the universe and about ourselves. The cosmos does not hand over its secrets quickly. It gives them slowly, grudgingly, through fog and noise and the restless interference of stars, through years of patient work and careful doubt. The answer to whether these worlds breathe will not arrive in a single bright moment. It will be earned slowly through more observations and more crossings and more painstaking separation of the planet's whisper from the star's noise, perhaps over many years yet to come. And there is something right about that, something fitting. The questions that matter most are the ones that resist us, the ones that make us wait, the ones that require us to sit at the edge of knowing without rushing to fill the silence with a comfortable answer. So do not feel that the uncertainty is a loss. Let it be a kind of peace instead. We live in a moment when one of the oldest questions has come close enough to touch and yet remains unanswered, suspended in the restless light of a distant ember. We do not know yet whether any of these worlds holds a sky. We do not know whether the flares strip them bare or spark something living in their air. We are not meant to know yet. The knowing is still being earned, patiently, by careful hands working against the noise of a stormy star. And there is a quiet grace in being alive at the edge of an answer, in holding a question this large and this beautiful, and being willing to let it stay open a little longer. The universe gives its secrets slowly. Tonight, let that be a comfort rather than a frustration. The restless star keeps its worlds half hidden, and the patient people keep working, and the answer drifts somewhere out there in the dark, not yet arrived, still on its way. Not knowing yet is its own kind of beauty. It means the wonder is not finished. It means there is still something vast and gentle waiting just beyond the edge of what we can see, circling a faint red ember 40 light years away, in no hurry at all to be understood. We have come a long way together, you and I, across a great distance, through patient explanations and quiet revelations, through the light of a faint red ember and the shadows of 7 worlds crossing its face. We have moved from a comfortable assumption about a bright and familiar sky into something stranger and truer and wider than what we started with. And now it is time to rest, to let the journey settle, to find its ending not in triumph or resolution, but in something softer, something that fits the hour and the dark and the slow closing of the mind towards sleep. So let me return you to where we began. At the start of all this, I asked you to picture the sky you thought you knew, the bright stars, the visible ones, the ones that catch your eye and carry names and fill the stories you grew up hearing. I told you that the sky you see is not the real sky, that the bright stars are the rare ones, the loud exceptions, and that the true galaxy is mostly dim, mostly red, mostly made of small, cool embers you will never see with your own eyes. I asked you to let that rearrangement happen gently, and I planted a question in you, a quiet, open loop, the question of whether warmth and water, and perhaps even life, prefer the loud, bright stars or the quiet ones. Whether the things that matter most in the universe gather beneath the grandest lights or in the calm, dim corners no one was taught to notice. I cannot close that loop with a clean answer. Not yet. No one can. But I can tell you how far the question has traveled since we opened it, and where it rests now, and why the place it rests is itself a kind of wonder. We still do not know if any of these 7 worlds breathe. Let that stand plainly, without softening, because it is the truth. After everything, after the discovery and the counting and the habitable zone and the locked faces and the great eye and the filtered light and the months and years of careful reading, the honest answer is that we do not yet know whether a single one of these worlds holds an atmosphere. The innermost ones appear to be bare. The most tantalizing one, the world called E, has offered hints, faint whispers in the light that lean toward a sky rich in nitrogen and touched with methane. But those hints have not hardened into certainty. They remain suspended, balanced between a yes and a no, tangled up in the noise of a restless star that refuses to let its worlds be read cleanly. We are closer than we have ever been. We are not there. And yet something enormous has changed. And I want you to feel the weight of it, because it is easy to miss in the disappointment of not yet having a clear answer. The change is not in what we know. The change is in what we are doing. For the first time in the entire history of our species, we are reading the air of Earth-sized worlds around another star. Not imagining it, not theorizing about it, not dreaming it in stories and hoping that someday the instruments might catch up. We are doing it right now, in our own time, with our own instruments. We are catching threads of starlight that have passed through the rims of distant worlds, and we are spreading those threads into their colors, and we are looking for the missing shades that would tell us what gases wrap those worlds. We are measuring the breadth of planets we cannot see, across a distance that light itself needs 40 years to cross. That has never happened before. In all the tens of thousands of years that human beings have looked up and wondered, no one has ever been able to do what we are doing now. The question of whether other worlds have air was, for the entire span of human civilization, until this very moment, unanswerable. It was a beautiful question with no way to approach it. Philosophers asked it, poets imagined it, scientists longed for it, and none of them, not one, had any means to reach across the dark and actually check. The question lived only in the mind. It belonged to the realm of imagination, of hope, of pure wondering without any anchor in evidence. And now it has crossed over. The question has moved from imagination into measurement, from dreaming into doing. From the long human tradition of looking up and wondering into the new and astonishing practice of looking up and reading, we have not found the answer yet, but we have found the method, and we have built the eye, and we have begun the work, and the first threads of light from distant atmospheres are already in our hands, being studied, being questioned, being slowly and carefully decoded by patient people who will not rush. That crossing from wondering to measuring is one of the great thresholds in the story of our species. It does not get the drama of a clear discovery. There is no single photograph to hold up, no headline that says it all. It is quiet, it is technical. It happens in the careful columns of data and the long months of correction and the cautious language of scientific papers that most people will never read. But it is a threshold all the same, and we have crossed it, and there is no going back. From this point forward, when someone asks whether other worlds have air, the answer is no longer, we cannot know. The answer is, we are checking. We are reading the light. The first results are ambiguous. More observations are coming. And in time, perhaps soon, perhaps not for years yet, the whisper of a distant atmosphere will resolve into a signal clear enough to trust. So the open loop does not close with a neat resolution. It closes with a shift in the nature of the question itself. We opened with wondering. We close with measuring. And measuring, even when it has not yet yielded its answer, is an entirely different kind of relationship with the unknown. It is the difference between staring at a locked door and imagining what is behind it, and actually putting your hand on the handle and beginning to turn. We have our hand on the handle. We are turning. The door has not opened yet, but the turning has begun, and it will not stop. Now, let me widen the frame one last time, because there is a larger reflection here, one that reaches beyond this single star and its 7 worlds. and it has to do with the reframe we planted at the very beginning. We grew up believing, without ever deciding to, that stars, like our sun, were the standard, the normal case, the kind of star that matters. We looked up and saw the bright ones, and assumed, naturally, that the universe was built around brightness. Our sun is a yellow star, warm and steady, pouring out generous light, and the worlds around it, our worlds, seemed like the natural template for what a planetary system should look like. Worlds spread wide, orbiting at comfortable distances, circling a bright and stable fire. That was the picture we carried. That was what felt normal. But the picture, as we have seen, is upside down. Our sun is not the common case. It is the uncommon one. The bright, warm yellow stars are a small minority, scattered thinly across a galaxy that is dominated, overwhelmingly, by the small red embers, the dim ones, the cool ones, the ones you cannot see, the ones that burn so slowly they will outlast the current age of the universe many times over. These are the true majority. These are the standard stars. And if the evidence continues to point the way it has been pointing, these ordinary, invisible, enduring embers may also be where most of the galaxy's worlds are found. Think about what that means. If the most common stars hold the most worlds, then the galaxy's planets are mostly orbiting fires you have never seen. Most of the surface is out there, most of the ground, most of the places where something could in principle stand or pool or stir, are circling dim red embers in the dark, invisible to your eyes, beyond the reach of the bright and familiar sky you grew up under. The real estate of the cosmos, the actual acreage of it, belongs mostly to the quiet corners, not to the loud and brilliant suns, to the embers. And our own sun, our warm, bright, generous star, may be the odd one out, the unusual case, the rare configuration that happened to produce one particular world with one particular sky and one particular kind of life that grew curious enough to look up and assume that its own arrangement was the universal norm. We are perhaps the exception, the uncommon case, the loud, bright star with widely spaced worlds, surrounded on all sides by the true majority, the dim and patient embers with their tightly packed families of worlds huddled close around small, warm fires we were never built to see. There is something humbling in that, and something freeing. Humbling because it asks you to release the quiet assumption that your world, your star, your arrangement is the center of things, the template, the way it is supposed to be. And freeing because it opens the sky into something far more populated, far more various, far more alive with possibility than the old bright story ever allowed. The galaxy is not a scattering of rare bright suns. It is a vast, dim, patient ocean of small red hearths, each one possibly circled by its own family of worlds. And we are one voice in that ocean, one small arrangement around one uncommon star, looking out at a cosmos that is far more full than we ever imagined. Let that settle in you now, slowly, because you do not need to hold it tightly. Let it be a background feeling, a gentle expansion of the sky inside your mind, something that will still be there when you wake, coloring your sense of the world just a little differently than before. Now come back from the distances and the stars and the red embers and the 7 worlds and the threads of filtered light. Come back to your body. You are here, wherever here is, a dark room perhaps, a pillow beneath your head, a blanket over you, the soft sounds of whatever surrounds you at this hour, the hum of a house at rest, the distant murmur of traffic or wind or silence. You are a body lying still on a world, and the world is turning. You can feel it if you listen for it. Not the motion itself, which is too steady and too large for your senses to catch, but the evidence of it. The night, the dark, the fact that your side of the earth has turned away from the sun and is facing out into the stars, and you are drifting in that turned away dark, held gently to the surface of a spinning world by the quiet pull of its gravity. And above you, between you and the cold of space, is the atmosphere, your atmosphere, the thin, warm layer of air that wraps this world, the blanket you have been breathing all your life without once stopping to wonder at it. It is there right now, pressing gently down on you, a column of air stretching from the ground beneath your body up through the miles and miles above you, thinning as it goes, growing colder and rarer until it fades into the vacuum of space. A few hundred miles of air, that is all that separates you from the emptiness. A few hundred miles of nitrogen and oxygen and traces of other gases, held in place by the gravity of the rock beneath you, warmed by the light of a bright and uncommon star, carrying the water vapor that will fall as rain, carrying the warmth that keeps the oceans liquid, carrying the breath that your lungs are drawing in and releasing, slowly, gently, in and out. As you rest, you have an atmosphere. You live inside it. Every breath you take is a negotiation with this thin, warm skin of air that wraps your world. And without it, everything you know would end. The water would leave. The warmth would flee. The breath would stop. You would be a bare rock, exposed and silent, the way those inner worlds of TRAPPIST once seemed to be. But you are not. You have a sky. You have air. You have the quiet miracle of an atmosphere holding you in its thin embrace, and it has been doing this for billions of years, patiently, without any instruction, without any effort on your part, wrapping this spinning world in just enough warmth and just enough pressure to let water rest and life grow, and a body like yours lie still in the dark and breathe. Notice that breathing now, just for a moment. The slow draw in, the gentle release, the air entering you and leaving you, the oldest and simplest rhythm of your life, the one that will continue on its own all through the night while you sleep. Each breath is atmosphere. Each breath is the air of a world that held its sky when so many others might not have. Each breath is evidence that, at least here, at least once, around at least one uncommon star, the conditions gathered and held, and the air stayed, and the water pooled, and the slow chemistry of life eventually stirred something into being that would one day look up and wonder about the rest. Let your eyes stay closed now. You do not need to look up. The sky is there whether you look or not. The stars are there. The faint red embers, the ones you cannot see, are there, glowing patiently in the dark, scattered across the galaxy in their billions, each one possibly circled by its own family of close, warm worlds. And 40 light years away, in the direction of a constellation called Aquarius, one particular ember is still burning, and its 7 worlds are still circling. And the world called E is still passing in front of its star, and the faint thread of light is still filtering through whatever may or may not be wrapped around it, carrying a message we have not yet fully read. Those worlds are there right now, as you drift, as your breathing slows, as the turning of your own world carries you deeper into the night. 7 Earth-sized planets, huddled close around a fire you will never see, some of them perhaps bare, some of them perhaps hidden beneath cloud, one of them perhaps, just perhaps, wrapped in a thin nitrogen sky with a whisper of methane, a sky whose existence we are only just learning to test. They are circling, they are locked. Their day sides face the ember in permanent noon. Their night sides face the dark in permanent midnight. Their twilight rings hold their soft eternal dusk. And they do all of this in perfect silence, 40 light years away, without any knowledge of us, without any awareness that on a small blue world orbiting an uncommon bright star, a mind is drifting towards sleep and thinking about them. There is something tender about that, about the way we reach across such distances with our minds and our instruments and our patience toward worlds that do not know we exist. We are not owed an answer. These worlds have no obligation to be what we hope. They may be bare, they may be veiled, they may hold wonders we have not imagined. Whatever they are themselves, turning in the dark on their own terms, indifferent to our longing, carrying their secrets with a patience that will far outlast ours. And still we look, still we send our greatest eye out into the cold, and we watch, and we wait, and we gather the faint light, and we try, slowly and humbly, to read what it says. Not because we are owed an answer, but because the question itself is worth the effort, because the asking makes us more than we were, because the willingness to sit at the edge of knowing, patiently, for years if necessary, and to let the universe reveal itself at its own pace, is one of the most beautiful things a curious mind can do. You do not need to hold any of it now. Let the distances go, let the star be faint, let the 7 worlds keep circling in the dark, neither proven nor disproven, neither bare nor breathing, simply there, simply possible, simply waiting for the next thread of light to tell us a little more. The great eye is still watching. The patient people are still working. The next crossing will come, and the one after that, and each one will bring a little more clarity, a little more signal lifted out of the noise of the restless star, a little more of the answer we have been waiting our whole history to begin to hear. And you are here, on a world that breathes, beneath a sky that holds, turning slowly through the night on a planet that kept its atmosphere and its water and its warmth long enough for you to exist, long enough for you to lie in a dark room and wonder about 7 worlds circling a faint red fire in the constellation Aquarius. Your sky is a little larger now than it was when we began, a little wider, a little more full of quiet, unseen embers and the worlds that might circle them. You did not lose anything tonight. You gained a truer picture of the galaxy you live in, a galaxy that is mostly dim, mostly patient, mostly made of small red fires with families of worlds pressed close, a galaxy that has been hiding its true face from you, not out of secrecy, but simply because its most common members are too faint for your eyes. The sky you carry inside you now has room in it for the bright stars you have always known, and for the dim ones you will never see. And the dim ones outnumber the bright ones by so much that the sky itself has changed shape in your mind. It is wider now, fuller, kinder somehow, for being so much more populated than you were told. Let that be the last thought you carry as you drift, a kinder sky, a fuller dark. 7 worlds circling a faint red ember in the quiet of Aquarius, neither proven nor lost, simply there, simply possible, asking nothing of you except the willingness to wonder. And beyond them, billions more embers scattered across the galaxy in every direction, each one patient, each one enduring, each one possibly circled by its own close, warm family of worlds you will never see, and no one has yet named. The dark is full, the quiet is full. The universe you are falling asleep inside is so much more crowded and so much more gentle than you knew. Breathe in, breathe out. The air of your world enters you and leaves you, and the night goes on, and the seven worlds keep turning, and somewhere, in the faint red light of a star no one can see, a thread of light is filtering through the rim of a distant world, carrying a message we are only just learning to read, a message that may take years more to understand, a message that is worth every moment of the waiting. Rest now. The sky will hold while you sleep. It always has. It is holding you right now, thin and warm and invisible, the atmosphere of a world that breathes, beneath a bright and uncommon star in a galaxy of embers. And when you wake, the seven worlds will still be there, circling their quiet fire, patient and unseen, keeping their secrets a little longer, waiting as they have always waited, in the long and gentle dark,